Guys, welcome back. We're on page 539. We're continuing on working in decimals and fractions. So, yesterday we worked a little bit on turning fractions into, like understanding how fractions and decimals were related, right? How we can move one from the other. Remember we talked a lot about money. Money is like the perfect example, right? So we're going to build on those skills. So, we also learned how to read decimals aloud. Who wants to read the first one aloud? How do we read it? Nolan?
Wait, what?
How do we read that decimal? Say it aloud.
3,500.
3,500. Beautiful. Who wants to read the second one? Amelia?
Is it
2.
700.
Not
No,
2 and
tens.
2 and 7
Oh
tenths.
yeah, 2 and 7 tenths.
Remember the decimal point we say and. Who wants to read the third one? Jacob?
6 and 1900.
6 and 1900s. Beautiful. Remember, we say the whole number, decimal point, and we say the number after the decimal point, and the last thing we say is the place value the last number's in.
I don't remember that.
Because we learned it yesterday and you weren't here. Watch the video from tomorrow. That's your homework.
He was here.
All right, so a soccer camp has places for 100 students. So far, 60 of the places are filled. Write both a fraction and a decimal in both hundreds and tenths to show the parts of the 100 places for students that are filled. So, how many kids can they take in total at the camp?
60.
100. How many have signed up so far?
60.
So you gotta write a decimal and a fraction that show how many parts are filled.
Okay.
So what's the whole here? 100. And how much is filled in so far?
60.
60. There you go. You have about 2 minutes to do that. Alright, so what is our first fraction gonna, what is our fraction? What is our whole number? What's the whole? 100, right?
Yeah.
100 is the whole. $100 is the whole. What's gonna go over 100? 100's in the denominator place, right?
60.
Xavier?
60.
60. Right? So, we have 60 hundredths, right? What is a decimal point going to look like for that? Chris?
Is it a 0 then a 60?
So this?
I think you mean 0.60.
Well, we don't call it that. What do we call it?
0 and 60 hundredths.
0 and 60 hundredths, right? Look like that, right, Chris? So 0 and 60 hundredths. That's why you're going to watch the video for homework tonight. Yesterday's video. You too, Chris, right? Did you miss the day yesterday? There you go. So, we have 0 and 60 hundredths, right? What else could a fraction look like that? Could we make this smaller? What could we take out of each one, Nolan?
A 0.
We could take a 0. What would that really be? That'd be dividing by what? Divided by 10, right? 60 divided by 10 is what?
60 divided by 10 is
6. 100 divided by 10 is what?
10.
So we'd have 6 over 10. 6 tenths, right?
Yeah.
What is 6 tenths of the decimal? 0 and 6 tenths, right? So is this the same as that?
Yeah.
Yeah. 0 and 60 hundredths is the same thing as 0 and 6 tenths. So what does that say about this 0 at the end right here? Does it matter?
Yes. A lot.
Does it? If this is the same as this, does that 0 matter?
No.
No, it doesn't. If we were doing whole numbers, would that 0 matter?
Yes.
But then, okay, say for example I write a number like this. Does this 0 matter?
Yeah.
The one to the furthest to the left matter?
No.
No, because it's still 100, right? That's just saying there's 0 thousands. Do these zeros matter?
Yes. Yes.
Because that's holding place value, right? It's the same thing if we write a number like this. These zeros don't matter. The one after the decimal point, all the zeros to the right don't matter. Just like at a whole number, the zeros to the left don't matter. Does that make sense? It's the opposite. Alright, you can use a model to understand how to write hundreds and thousands, hundreds and tenths as a fraction in a decimal. Each mile represents the parts of 100 soccer camps, 100 person soccer camp place that are filled. 100 soccer camp places that are filled. Okay. Didn't make sense for a second. Alright, so look at, we have a square, right? What is that square divided into? Raise your hand, please. Orion? Hundreds, right? So there's 100 little squares there, right? If we fill 60 of them in, it would look like this, right?
Mm-hmm.
Now, can we divide that into a smaller group?
Yeah.
Less groups? Yeah, because they're each a column, right? How many is in each column?
10.
10, so can't we just make each column a spot, so we divide 100 into 10 pieces, right? It's the same cube, correct? And really, there's the same amount of places, right? But we just divided it by 10. So each small square is 1/100th of the whole, right? Each one is 1/100th, correct? We shaded in 60 of them. So 60 hundredths of the whole is shaded in, right? 60 out of 100. Now if we take these and we get rid of all the side columns and just break it into 10 pieces, now each is 1/10 of the whole, right? Each bar is 1/10. 6 sections are shaded in. So we have 6 out of 10. 6/10 of the whole is shaded in. Does that make sense how we did that?
Yeah.
What did we kind of just do here? Really? Remember way back in the very beginning when we first started talking about fractions, what did we do?
We added them.
Nah, just adding them. Before that even. No, before we did that.
That's about the word.
The first section started with an E.
Equivalent?
We found what? We found equivalent fractions. Is 60 over 100 equivalent to 6 over 10?
Yes.
Yeah, we can take a 10 from each side, right? So what are we finding now? We're finding equivalent fractions and equivalent what? Decimals. 60 hundredths is equivalent to 6/10. Does that make sense now? If a fraction if a decimal as a fraction are equivalent, then the decimals must be equivalent as well, correct? If 60 over 100 is equivalent to 6 over 10, then 60 hundredths has to be equivalent to 6/10. Does that make sense?
Yes.
You can use a place value chart as well to do this, to understand how to write hundreds or tenths of decimals. The place value chart shows 60 hundredths. We have ones, we have 0 ones, right? Decimal point, decimal point. Tenths, we have 6 of them. Hundredths, we have 0 of them. Make sense?
Yes.
That's just to make it easier for you to write decimal points. Or write the numbers. Look at the first mile. The mile on the left shows 60 squares shaded, right? We have 60 of them shaded in. Write a fraction for this mile. What would the fraction be for that model? Raise your hands, please. Katie? The red one, the red model. What would the fraction be? 60 over 100, right? The model on the right shows 6 sections shaded in. What is the fraction for that model? Michael?
6/10.
6/10. How does the model on the right, in the first model, show you the fraction that you wrote for the model in problem 1? How does the model on the right in the first model Oh, how does it show? How does that model show 60 hundredths? Amelia?
Because it has 100 squares and then 60 shaded in.
It has 100 squares and 60 of them are shaded in. Alright, number 3. Look at the place value chart in the second model. Write a decimal in tenths and that is equivalent to that decimal in hundredths. How are the two decimals different? So, this one we have 60 hundredths, right? What is the decimal equivalent to that? Raise your hand, please. Close. 6/10, right? So it's equal to 60 hundredths, right? What's different about those two? Michael?
One has a 0 at the end.
0 in what place?
And it's 100.
One has a 0 in the hundreds, right? Number 4. Write a number on each line below to describe how decimals relate to fractions with denominators of 10 and 100. So, if the denominator of a fraction is a 10, the equivalent decimal has a place after the decimal point. The equivalent decimal has blank place after the. How many place values go after if the denominator is 10? Chris? 1, right? If the denominator is 10, how many place values are we going after the decimal point? 1. Does that make sense?
Oh, yeah.
If the denominator of a fraction is 100, how many place values are we going after the decimal point?
2.
Raise your hands, please. Sid?
2.
2. Does that make sense what they're asking there?
Yes.
They're asking how many places after the decimal point, right? If it's got 10, you just go 1 place. If it has 100, you go 2. Reflect. Look back at your try it. Strategies by classmates. Skip it. Number 6. Write a decimal equivalent to 2/10. Draw a model that shows the fraction and the decimal. Show your work. So you're going to write the decimal that is equivalent to 2/10. 2 out of 10. And then you're going to draw a model that shows the same thing. So write the decimal and then draw the model. All right. What is a decimal equivalent to 2/10? Caden?
0 and 2/10.
So it's going to look like this, right? Like that, right? 0.2 is what you should have. Remember, we're not looking for a fraction that's equivalent. We're looking for a decimal that's equivalent. I see some of you just wrote the fractions that were equivalent. You wanted the decimal. We got to draw a model for it, right? So what's my model going to look like? Amelia?
You're gonna have 10 blacks and 2 colored.
Yeah. You're going to have 10 of them, right? And 2 shaded in. Make sense?
Yeah.
How many had that? Right.
I just didn't have the model.
Right.
I kind of had the second part, but I didn't have the first part.
All right. Here, you're going to try this one. Write a decimal that is equivalent to 83 over 100. Show your work. So write your decimal that's equivalent to 83 over 100. Not a fraction, a decimal. All right. What is this? Who wants to go up and write this one down for me? Katie, come on up. Show us what it looks like. No, you gotta write the decimal. So we have 0 and 83 hundredths. How many had that? Raise your hand if you had that.
I got it. Yes.
Okay, good deal. And then our exit ticket. Write 7 and 9 tenths as a decimal. So write that mixed number as a decimal. When you get it done, raise your hand. I will come and make sure you got it done right. Once I give you the nod, go ahead and you can start the green pages. If you're good. You got it done yet? Good. No, not quite. No. Yeah. Good. Don't draw model, Kaden. Good. No. It's just like writing the ones up above. Only we have a whole number. Instead of a 0. It's not going to be a 0. It's going to be a what?
7.
Yeah. Yes. No. Down. No. You got it. Yes. Don't copy. No. Yes.
It's not going to be 0.
No. Yes. 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 Don't put it over a number though. It's a 7.9. Yes. No. Yes.
And now we work on our agreement.
Yes. I don't know. I'm not working with that right now.
You just said it. 7, 9. You don't divide it. So what would you
Start
do?
working. Stop putting it down.
7, 9. No.
Who still needs to be get it done?
7.9. So it would be 7.9. Just
And you're-
7.9.
What's the whole number?
7.9.
7. Put your 7 down. That's what decimal point. Now I have 9 tenths, right? Right, 9 tenths with the decimal. 7. You're right. That's right. There. That's all you need. Yes. Who else needs me to see it? Did I get everybody? Alright. For those at virtual, remember, we put our whole number first. So we have 7. And then we just gotta write 9 tenths as a decimal. So 9 tenths of decimal is just that. And that's all we need to have done. Alright, virtual kids, online kids, you're working on the green pages, page 243 and 244. We'll see you tomorrow.
No, yeah, tomorrow.
Tomorrow we will see them.
Like and
We'll see you tomorrow.
subscribe.
Subscribe.
Yeah, like and subscribe as they say.